Okay, in this video I'm going to be going over the calculator section of the test. Before I begin, I'm going to remind you guys of all of the formulas that we learned. This one is your main one. And the reason why we have these other formulas is because we don't always know what the constant multiplier is. This original formula you get to use when you do know what the constant multiplier is, and you will hear keywords like double or triples or quadruples, etc. Or they might tell you that it increases by 1.5 every single time. And here, you're going to use it whenever you hear the word percent. But this one, you're going to use when you have the word percent, but also the word compounded. And then lastly, this one you will use when you hear the word continuously. Okay, let's see how that applies into our test. So we have that Ashley is contemplating depositing $550 into a savings account at Laughing Vault Bank, which offers a 4.15% interest rate, compounded daily. I hear those two pieces of information in the same sentence, percentage and compounded. So that's going to be that first equation. I'm going to figure out how much money she will make in 41 years. So my P is 550. My R is going to be 0.0415. And it's compounded daily. This formula is in reference to a whole year. So how many days do you have in a year? 365. And then to the power of 365 times 41 years. So I'm going to go ahead and put this into my calculator. Plus 0.0541 divided by 365. Okay, and I get that she made $2,953 with 73 cents. However, her friend Yuvia proposes investing the money in Bitcoin, which pays a 3.9% interest, compounded continuously. So that's going to be the upper formula. So initial value 550 times e to the power of 0.039 times 41 years. Oh, my heart hurt so much when I saw your test, because some of you, instead of putting 0.039, you put the same percentage as that first one, and that's why you got it wrong. Okay, so I'm going to put that in my calculator. And we get $2,721 with 45 cents. So you can see here that Laughing Vault Bank is still a better place to invest Ashley's money. And then you had to answer that question, how much more money would she make with the better option? So you would do $2,953 with 73 cents minus $2,721 with 45 cents, and you get a difference of $232.28. Okay, and then we go over to number 2. Ashley's friend Mario actually knows a sketchy dude who pays a 55% interest rate every month if you invest in his quotation mark business. How much money would Ashley have in 2 years if she gives her money to the sketchy dude instead? Okay, so we hear the word percentage, but there's no compound it in our sentence. So it can be that first one. And the only other one that it can be continuously. It can be a PERT because we don't have the word continuously. So the only other one that has the word percentage is C. So we have the initial value is still 550. That's how much Ashley has. Times 1 plus 0.55 to the power of x. And then in this case, the x is actually 41 years, right? Oh no, sorry, 2 years. If you put 1 plus 0.55 in your calculator, or you do it in your head, you'll see that it's 1.55x, right? Oh my gosh, doesn't that look like that original formula? The reason why it's formula C, not formula D, is because they didn't tell us that it increases by 1.55 every month. And it's also a weird thing to say. It's easy to say that something doubles or that something triples. It's much harder to say or to word it in a way where you're showing that it's increasing by 55% every single month. But your constant multiplier in this case would be 1.55. Okay, anyway, let me replace that x with 2. And I'm going to put that in my calculator. 550 times 1.55 to the second power. And you'll see here that Ashley makes $1,321.38. Right, you can also... Actually, never mind, it's fine. Number 3. Ashley's friend Huiling proposes an alternative investment opportunity. After 15 years in the secret bank, Ashley would accumulate this amount of money in a secret bank that compounds your interest weekly. Okay, again, compounds, and we have a question about the interest rate, right? So that's still going to be formula A. We know that Ashley starts out with $550. We know that the interest rate is unknown, and we know that it's compounded weekly, so there's 52 weeks in a year, and then it's 15 years that she puts that amount in the bank, and then after 15 years she makes $1,163.93. Okay, step 1 is to divide both sides by 550. So we have 1 plus r over 52. And then I like to do the exponent in this step. So I like to simplify the exponent in this step. So I'll do 52 times 15 in my calculator. And I'll get 780. And then 1,163.93 divided by 550 is 2.11624. Okay. From here, what I'm going to do is I'm going to take a log on both sides, because what this is going to allow me to do is going to be to put the exponent as a coefficient. So it's going to look like this. Log of 2.11624. Okay. If you got up to this point in your test, you're doing a good job. You're almost there. What you need to do next is to divide both sides by 780. And then you'll have log of 1 plus r over 52 is equal to, just put this whole thing in your calculator. Okay, let me do it in mine. So I have log of 2.11624, close the parentheses, divided by 780, and we get 0.000417. Okay, and then again, we died here, right? Logarithmic form, no longer of use to us. So make it exponential form. Make it so that it works for you. 10 to the power of 0.000417 is equal to the argument 1 plus r over 52. Okay, I'm going to put this in my calculator. 10 to the power of that decimal, and I get approximately 1.00096. Next, I'm going to subtract 1 from both sides, so I'm going to get 0.00096 equals r over 52. And then I have to multiply both sides by 52. So multiply both sides by 52. When I do that on the calculator, I get that r is equal to 0.05. And then if you want a 4 and not a 3, you would rewrite that in percentage form, so 5%. Okay, part 6 was a little spicy. It's a little bit of SAT practice and seeing how much of the skills that you've learned in this unit you can apply to something that you had no preparation. So I did hear your complaints like, oh, this wasn't on the relay. Yeah, because this is not a test of like, can I see something and then copy it? It's more of like, what skills have I accumulated over the chapter? And now I can apply it into something new in a situation that I've never seen before. Think of your apply habit of mind. Okay, anyway, you have, because atoms and molecules are very small, they are counted in units of moles, where 1 mole is equal to 6.022 times 10 to the 23rd molecules. Concentrations of molecules in a liquid is measured in units of moles per liter. The measure of acidity of a liquid is called the pH of the liquid, and it's given by the formula pH is equal to negative log of H, where H is the concentration of hydrogen ions in units of moles per liter. And then number 1 is asking you, well, if water has a pH of 7, how many hydrogen ions are in 1 liter of water? Do you notice how the two things that are highlighted in yellow are the same thing? And what is the variable that represents the concentration of hydrogen ions? Well, wouldn't that be H? Yes, it would. So what they're asking you to do is like, okay, replace the pH value in that equation with 7. So we have 7 here. And set it equal to negative log of H. And we are solving for H. We're solving for the number of hydrogen ions in 1 liter of water. So first step is to divide both sides by negative 1. And so now we have negative 7 is equal to log of H. And back to the idea that we talked about in the beginning. A logarithmic form is no longer of use for us in this situation, right? There's nothing that I can do here, no matter what calculator I put it in, that will give me a number. So turn it into exponential form. 10 to the power of negative 7 is equal to H. Oh my gosh, that's exactly the variable that I wanted to find. H is equal to 10 to the power of negative 7. Great, that's your answer. If it was more helpful for you to see it as a decimal form, you can turn it into decimal. Remember, what this means is that you take that decimal at the end and you move it 7 times to the left because it's a negative exponent. So we're going to go like this 7 times. And you will get a number that has point and then 5 zeros and then a 1 in the front. So this could have also been your answer. Or I actually saw somebody do it like this, 1 over 10 to the power of 7, which is exactly it. Okay, great. Now that you know how many hydrogen ions are in 1 liter of water that has a pH of 7, that would have been enough to get a 2. But it's also enough information to go on to the next question. If a liquid has a pH of value larger than 7, does 1 liter of that liquid contain more or fewer hydrogen ions than 1 liter of water? Okay, let's play around with it. What is a pH value larger than 7? I don't know. Maybe a pH of 10. Actually, let's do a pH of 9. So substitute pH with 9, and now we have 9 equals negative log of H. Divide both sides by -1. And now we have -9 equals log of H. And 10 to the power of -9 equals H. Okay, so in this, I just randomly chose a pH that is bigger than 7. I chose 9. I could have chosen 10. I could have chosen 12. I could have chosen 8. It doesn't matter. We're just testing it out and seeing what happens. And what happened was that I ended up with a number that is way smaller than a liquid that has a pH of 7, right? What does that mean? That means that you take your decimal place at the end and you move it 9 units to the left. So you end up with 0.000034567, right? That's how much smaller this, that's how many less hydrogen ions are in this liquid. Why? Because there's going to be an inverse relationship between the number of, between the pH of a liquid and the number of hydrogen ions that exist. Think about it. Imagine that you had a pH of 13. I don't even know if the pH scale goes that high. But imagine if it did. What would your pH be? How many hydrogen ions would you have? Well, given that we've seen the pattern, we would have 10 to the power of -13, right? Which is an even smaller number than a pH of 7. So to get credit for this question, it would just explain that as the pH increases, the number of hydrogen ions decrease because there is an inverse relationship between the pH of a liquid and the number of hydrogen ions that it contains. Okay, number 3. Suppose that a liquid A is more acidic. So here I'm going to have liquid A, and it's more acidic than liquid B. Liquid B is right here, and it's more basic. And their values differ by 1.2. So what does that mean? That means that whatever the liquid A is, liquid B has a pH of X plus 1.2. You need to understand that the more basic something is, the higher a pH it's going to have. And I did give you that background information before we started the test. Okay, anyway, let's use the equation that was given to us at the beginning. Let's use that equation. So you have the pH of A is equal to the pH of B, but we have to subtract the 1.2 because remember that pH of A is less acidic than the pH of liquid B. Okay, let's maybe put the 2 pHs on the left side. You don't have to do it. There's an infinite ways of solving this problem, but this is how I'm going to do it. I'm going to move both pHs to the left, and I'm going to say, well, now that's equal to -1.2. Great. What is pH of A? This is no longer useful to me. Maybe I can substitute something. Well, I know that pH of A is going to be the same thing as negative log of H sub A. So replace this whole thing with negative log of H, and I'm going to put a little subscript with the letter A so that I know that it refers to the liquid A. Okay, minus, replace all of this with negative log of H sub B. Okay, can we simplify things a little bit? Yes, we can. I can see here that there are two negative signs, and when you have two negative signs, you can turn it into a positive. So negative log of h sub a is plus log of h sub b is equal to negative 1.2. Okay, well, let's start by dividing both sides by negative 1. What's going to happen? It's going to switch the signs of everything on the left side. So it's going to become log of h sub a minus log of h sub b equals 1.2. Okay, well, you're subtracting two logarithms that have the same base, so make them a division. Log of h sub a over h sub b is equal to 1.2. This is no longer useful to us. Turn it into exponential form. 10 to the power of 1.2 is equal to h sub a over h sub b. Okay, what happens if we put 10 to the power of 1.2 in the calculator? We get 10 to the power of 1.2. We get 15.8489 h is equal to h sub a over h sub b. Well, isn't that already a ratio? Isn't that what the question was? What is the ratio of the concentration of liquid A to the concentration of hydrogen ions in liquid B? It's approximately 15.8. So in other words, liquid A has about 16 times the amount of hydrogen ions that liquid B has. If you wanted to be exact, you could have said 15.8. And that's it.